In this video, we will show the relationship of NORMSDIST function, Gauss function, ERF function in relation to the Gaussian integral. Begin with the Gaussian integral, which is the summation of the a times x to the power 2n plus 1, where the value of a is negative 1 to the power n over n factorial times 2n plus 1. And the value of n is from 0 to infinity. So we can start from 0 to infinity. 16 is good enough. So we generate the Taylor-Maclaurin SERIESSUM dataset. So RA formula, series sum of the x values raised to the power 2n plus 1, where 2n plus 1 begins with 1, incremented by 2n, where 2n is 0, 2, 4, 6, 8, and so on. So the interval is 2. And the coefficient will be this range. And here you have the trend line and the polynomial of the Taylor-Maclaurin series sum of the Gaussian integral. We continue with the coefficient, which is RA formula, negative 1 to the power n. That's the numerator, divided by, now the denominator has two parts. The first part is factorial n. So factorial n. The second part is 2n plus 1. So the quantity 2 times n plus 1. Enter. So here you have the trend line of the Gaussian integral and the polynomial of the Gaussian integral to the degree 8. We'll calculate LINEST later, which is, here we use the LINEST. So LINEST, that is RA formula, the LINEST matrix of the x values raised to the power 0 to 8. And this will be equal to LINEST of data y and data x. So here you have the polynomial regression coefficient. So x to the 0 is 0. X, that's 0.997. X squared 0. X cubed minus 0.313. X to the 4th 0. X to the 5th 0.0696. X to the 6th 0. X to the 7 negative 6.54 times 10 to the minus 3. And x to the 8 is 0. We continue with the ERF function. Begin with the ERF. So this is RA formula, ERF of the x values. Then we factor in 0.5 times square root of pi. So that's 0.5 times square root of pi. Now they're all on the same trend line. And the polynomials are also the same. We calculate the regression coefficient using LINEST. So LINEST, data y, and data x. And we get the same results for the polynomial regression. We continue with the Gauss function. So this is equal to RA formula, Gauss of the x values. and we factor in square root of 2. So times square root of 2. Getting closer? Then we multiply square root of pi to Gauss. So that's times square root of pi. Square root of pi. And they're all on the same trend line. And the polynomials are also the same. We calculate this polynomial regression coefficients using LINEST. So this will be equal to LINEST theta y and theta x. And we get the same coefficient, regression coefficients. And finally, we go to the norms test. So this is equal to R formula, norms test of the x values. And we multiply square root of 2. So times square root of 2. Now that we've multiplied by square root of 2, the next step will be add negative 5. So minus 0.5 plus norms test. We're getting close. Then multiply square root of pi to the quantity. So that's quantity multiply square root of pi. Enter. They're all in the same trend line. Their data sets are all equal. And the regression coefficients are also the same. We have the same regression coefficient. We'll calculate this polynomial regression coefficients using LINEST. So this will be equal to LINEST data y and data x. And the results are the same. So x to the 0 is 0. X will be 1 or 0.997. X squared all 0. X cubed is negative 0.313. Negative 0.313. X to the 4th is 0. X to the 5th 0.0696. X to the 6th all 0. And x to the 7th negative 6.54 times 10 to the minus 3. They're all the same. X to the 8th, they're all 0. This completes the use of NORMSDIST GAUSS error functions to calculate the Gaussian integral and using LINEST polynomial regression.